For this exercise, we have a rational function. First, we'll find its domain, then we'll use several steps to graph the function. So we have 4x squared over x squared plus 3 for our f of x. Let's first look at the domain. We find the domain by letting x equal any real number except a value that makes the denominator 0. So let's set the denominator equal to 0 and solve. X squared plus 3 equals 0 means x squared equals negative 3. What happens if I take the square root of both sides? I would get x equals plus or minus the square root of negative 3. This is not a real number. This is an imaginary number or a complex number. Therefore, there is no value that will make the denominator 0. So therefore, we can say that our domain is any real value from negative to positive infinity. We can let x equal any real number. Now let's move on to step 1 in order to help us graph this function. In step 1, we always want to check to see if we have any symmetry to help us with the graph. In order to check for symmetry, we really need to look at f of negative x and compare it to f of x. Well, f of negative x is 4 times negative x quantity squared over negative x quantity squared plus 3. Well, let's simplify. The numerator just becomes 4x squared, and the denominator becomes x squared plus 3. Notice this is exactly the same as our original given function. So when f of negative x is equal to f of x, we can say that the function is even. This will help us in our graphing because all even functions are symmetric with respect to the y-axis. Let's move on to step 2. Let's see if we have a y-intercept. We find our y-intercept by letting x equal 0. In other words, find f of 0, and we get 4 times 0 squared over 0 squared plus 3. That's just 0 in the numerator over 3 in the denominator, or 0. So in other words, our y-intercept is 0. Notice when I plot that y-intercept of 0, that also automatically implies that the x-intercept of 0 is there as well. But we still need to check in step 3 to see if we have any other x-intercepts. We find x-intercepts by letting y equal 0. In other words, we set f of x equal to 0, and we set 0 equal to the numerator of our rational expression, or our rational function. 0 equals 4x squared. If I divide both sides by 4, I get x squared equals 0. The only solution to that is x equals 0. So even though we already knew x equals 0 was our x-intercept, we needed to check to make sure there were no more, and there are no more. So let's move on to step 4. Let's see if we have a vertical asymptote. We get the vertical asymptote by setting the denominator equal to 0. Remember, we did that when we were looking at the domain, and we did not get any real number solutions. We only got an imaginary solution. Therefore, we can say there are none in terms of vertical asymptotes. Let's check to see if we have a horizontal asymptote. For any horizontal asymptote, we compare the degree of the numerator with the degree of the denominator. The degree of the numerator is 2. That's the highest power up in the numerator. Also, the degree of the denominator is 2. That's its highest power. So, we can say that we do have a horizontal asymptote. It is going to be y equals, we just take the ratio of the coefficients, 4 over 1. Or simply, y equals 4. Before I go on into number 6, I'm going to plot the pertinent information to help me choose a few more points. We know we do have symmetry. We know that this graph is going to be symmetric with respect to the y-axis. So we really don't need to pick quite as many points in number 6. We have already plotted our x and y intercept. We do not have a vertical asymptote, but we do have a horizontal asymptote. It's the line y equals 4, so it just crosses through 4 on the y-axis. Now, we're ready to pick some points. We'll just pick a point to the right of the y-axis, and we can, by symmetry, plot that point to the left of the y-axis. So we might pick a couple just to get an idea of what it looks like. Let's start by letting x equal 1. It's really not important what value you choose as long as it's to the right of the intercept. If x equals 1, I substitute that into this original function. I also get a function value or a y value of 1. So 1, 1 is a point on my graph. And let's pick another one. Let's let x equal, say, 2. If I substitute 2 into my original function, I get the function value of 16 over 7. So that's a little bit more than 2. So when x equals 2, the function value is a little bit more than 2. So by symmetry, we can plot the point negative 1, 1, and also negative 2, 16 over 7. And then we'll sketch these with a smooth curve. We know it's going to tend toward the asymptote, and it's symmetric. So here is a sketch of our rational function.